Welcome to aminacademy.com. In engineering mechanics regarding motion of connected bodies, let us discuss about motion of two bodies connected by a string and lying on a rough inclined plane. Look at this figure. The surfaces AB and BC are inclined at alpha 1 and alpha 2 and masses are connected by an inextensible string M1 and M2. Then here this is normal reaction R1. Here the normal reaction is R2. In this case, the friction between the bodies of masses M1 and M2 and the surface AB and BC will be considered. Now let here angle of inclination angles of inclinations are alpha 1 and alpha 2. Masses are M1 and M2. Now mu equal frictional coefficient. Frictional coefficient of bodies and the surface, rough surface. Let A equal acceleration of bodies. Both bodies acceleration is same here. And now we'll consider the body 1. In body 1, that here the force due to weight come down due to that frictional force acting this side and tension acting that side. Therefore, you can write resultant force M1 G sine alpha 1 minus tension minus frictional force mu R1, which is equal accelerating force is mass into acceleration, that is M1 into A. Let it be 1. And for body 2 is here, body 2 is moving up, so it is tension minus force M2 G sine alpha minus frictional force mu R2, which is equal accelerating force equated mass into acceleration M2 into A 2. Now adding 1 and 2, we get M1 G sine alpha 1 minus T minus mu R1 plus T minus M2G sine alpha 2 minus mu R2, which is equal to M1A plus M2A. The tension cut both sides. Then the final, this M1G sine alpha 1 minus M2G sine alpha 2 minus mu R2 equal A into M1 plus M2. This expression, from this expression we can find the value of acceleration as well as that acceleration substituted in equation 1 or 2, we can get the tension in the string. For this concept, we will do some example problem from basic concept. Example, two rough planes inclined 30 degree and 15 degree to the horizontal and with the same height are placed back to back. Two bodies of masses 15 kg and 5 kg are placed on the faces and connected by an inextensible string over the top of the planes. If the coefficient of friction is 0.3, find from the fundamentals the resulting acceleration. Look, this one is mass 15 kg. This is 5 kg, and the this tension is here. This angle of inclination is 30 degree, here 15 degree. Now we will do this problem from fundamental concept, that is A equal acceleration of bodies, T equal tension in string. Here we consider body 1 and here body 2, and here mu equal 0.3. The first body 1 is normal reaction. R1 is body mass is 15, 9.8 into cos 30 degrees, which is equal, gives 127.3 Newton. Then frictional force. Frictional force is mu R1, which is equal 0.3 into 127.3, which gives 38.2 Newton. Body 2 considered, here R2 equal 5 into 5 kg, 5 kg and 9.8 into cos 15 degrees, which gives R2 is 48 Newton. The normal reaction mu R2 equal 0.3 into 48, which gives 14.4 Newton. Now here the resulting force on the body 1, that means the body comes down, so the force acting this side and tension acting this side and frictional force acting this side. Therefore resultant force is, that is, the resultant force is m1g sine alpha 1 minus t minus mu r1, which is equal, mass into acceleration is 15 a. So by putting the values and simplifying, which is, that is 147 into sine 30 is 0.5 minus tension mu r1 is 38.2 equal 15a. So that is, finally we have 35.3 minus tension equal mass into acceleration is 15a. This side resultant force is m2g sine alpha 2 tension minus sine alpha 2 minus mu r2, which gives T minus m2 is mass is 5 into 9.81 into sine sine 15 minus mu r2 we have 14.4. So final which is equal m2, that is mass is 5a. 5 is mass, acceleration is a. By simplifying we'll get t minus 27 equal 5a. Let it be, put 1, this is 2. Now adding 1 and 2 we'll get simplification. 1 plus 2, that is gives 35.3 minus t. This side is t minus 27, 27. This side, right side is 15a, that right side is 5a plus. So this tension and tension cut, therefore acceleration is 35.3 minus 27 over 20, because 15 plus 5 is 20, that is 42 point 0.42 meter per second square. This is acceleration. We have done. Please subscribe our YouTube channel.